All right. Thank you all for joining in. It's so weird to do this with an audience that all have their headphones on, but really thank you all for joining. Thank you AWS for inviting Poolside to this AWS Summit. This one feels special to me, not just because Poolside was at AWS Summit in Paris last week, where our founder did one of the keynotes, and we'll be in London as well in 2 weeks. But this one feels special to me because Amsterdam is my hometown, and I remember an AWS event as one of the first events I visited as a software developer myself many years ago. So it feels like many things are coming together at this talk. So thank you all for joining. How this is coming together is by giving you our take and really my perspective on what the future of AI for software engineering will look like. I could have named this talk like the future of software engineering. I could have even named it the future, but I'm not sure how well attended this talk would have been if it was just the future. But many of these things are coming together in this title. My name is Sebas. I'm Director of Solutions Engineering at Poolside. Before I was at Poolside, I was 6 years, almost 7 years at this company that you probably all know, GitHub. And before that, I was at WeTransfer, which is a well-known Dutch tech company. I'm based out of Amsterdam. I've been playing with software engineering my whole life, and I have strong opinions when it comes to software engineering. And I will talk a little bit about this in the next 45 minutes. And I also want to invite you to our Poolside booth later today, so we can continue some of the discussions on this topic. AI, it's hard to understand what to focus on, especially as a decision maker. It's AI everywhere. So I want to start off this talk by taking a small step back and really looking at what the market actually looks like. I will simplify it for you, because this will help you to make the right decisions when you think about AI for software engineering. This is the reality we live in today. There are AI makers, and there are AI consumers. AI makers, I think you all know them. It's OpenAI, Anthropic, xAI, Mistral, some Chinese companies working on this as well. But it's really a handful of companies that build AI models. And then there's the AI consumer side of things. This is a market where it's hard to keep up to date on what is exactly going on. What is the next hot thing you should adopt? There we see Copilot, there we see Tab9, Cursor, Cody, there's Cursor, there's Windsurf, and probably a new company comes up there every 2 weeks or so. These companies are really good at building that middle layer between the user and the model maker. They focus on a user interface, and they prompt the models and filter the suggestions coming out of these models to the user, so the user can implement this. They all rely on these general purpose models. Where Poolside sits, and really if there's one thing you take away from the next 40 minutes, Poolside sits in the middle. We make models specifically for software engineering, as well as the end-to-end user interface and all the different interfaces you need as a company to interact with that model. There's more to this when you think about the AI landscape. And I've seen this when I was at GitHub, and I see this in a way when I talk to companies today at Poolside as well. There is an acceptance that AI is changing how we do software development. When I was talking to some decision makers 2 years ago, they considered AI a nice tool, a nice utility that developers could use in their IDE, but nothing more than that. They were not thinking strategically about how to adopt AI for software development. If I talk to people now, then they all agree. Well, let's say 98% of the people I talk to, I know some of you also have strong opinions on this, but 98% of the people I talk to, they agree AI is changing how we do software development. We need to think differently about how we do software development. Then, as we think about these AI makers, these are general purpose models. These models are really good at predicting the next token. But where these models struggle is when it comes to complex and deep software development problems, but also complex business environments. So what can be table stakes today is in that same reality we're hitting a ceiling because these general purpose models are made to do next token prediction. And then something that hasn't changed in the last 20 years is like development teams are under pressure to deliver software and to do this in a secure way. From a developer's perspective, and I feel strongly about this because I talk to developers every day, I spend time in my IDE myself every day. There's kind of tool fatigue, like there is the next hot thing. It was step 9, then Copilot came, then Cursor, now it's Windsurf, there is Lovable. Like, what is the next hot thing you should adopt? And from a business perspective, it's even more challenging because you want to decide on a tool and give that to your developers so they can do their best work. At the same time, I was reading a post by, I believe it was Shopify last week. Some companies have a mandate that their developers, they need to use AI in their software development workflow. And that AI gives them value, but at the same time, especially in these complex business environments, general purpose models are not good enough, and this leads to frustration among these developers. Then there's the last hot topic, like what decision makers and engineering leaders need to deal with. You're sending a lot of data over to these tools and to these model makers. If you use Cursor, you send it over to them, and then they send it to an Anthropic or an OpenAI or a Gemini. And if we work under the assumption, and for me this isn't an assumption at all, I think this is the reality already today, that we need to send more data over to these models to get to the results we want, to get more value out of this, then this is a one-way street. You continue to send over your IP and business data over to these models. And that creates a dependency. So as these models become more strategic, this is increasingly challenging. And many companies have signed off on exceptions for using these models and sending their data over to the cloud. Okay, let's go back in time to rephrase this a little bit. Iso Kant, he's one of our co-founders. He's been invited to the World Economic Forum for a few years already to talk about software development and to talk about AI. Beginning of 2024, there were discussions about AI, but the general consensus is this will have a huge impact, but only within 10 years or so, there will be this concept of AGI for software development. Now we go to this year, 2025, World Economic Forum. He's invited again to talk about this. The consensus is within 5 years, we get to AGI for software development. We at Poolside think we'll get there within 18 to 36 months. So, brings me to my next topic. Why does Poolside exist in the first place? Why are we building Poolside? And this is easy to summarize. If anyone of you comes to me today and asks me this question, our mission and only focus is to build AGI for software development. Not for anything else, but for software engineering. I'll talk a bit about how we do this in a few minutes, but I want to take a small step back and talk a little bit about our founders. Because even though Poolside was only founded 2 years ago, I think this already started in 2016. 2016, GitHub, our CTO, Jason, I had the pleasure to work with him at GitHub as well. He got in touch with Iso Kant, born in the Netherlands as well, so shout out to Iso. We at GitHub, we wanted to acquire Iso's company. It's a company named Sourced. Probably it was the first company that wanted to leverage AI to make developers more productive and efficient and to help them in their software development work. Too early, the technology wasn't there yet, We didn't see an OpenAI, large language models, like it was too early days. ISO also rejected this, like he didn't want to get acquired by Poolside. So a few years later at GitHub, Copilot was incubated by Jason, our CTO, who also worked on things like GitHub Actions, search, and you name it. Foundationally, GitHub Copilot was built to rely on OpenAI, although it also supports other models today. Was good enough back then, but we have a belief that there is something fundamentally, that something needs to fundamentally change if we want to get more value out of these models and to give businesses control over what they do. And that has 3 pillars, but one of the most important pillars is that you need to build foundational models for software development. What I mean with this, when you drive, maybe Tesla isn't the best example these days, but when you drive your Tesla, it is trained, its AI is trained on traffic situations and how cars behave. In healthcare, it's AI models specifically trained for healthcare. These industries, they don't rely on general purpose models. But to this day, for software development, we do rely on general purpose models to do the work we do. And it has moved the needle, definitely, over the last few years, but we're also hitting a ceiling when it comes to this. So we're building foundational models through a technology, proprietary technology named reinforcement learning through code execution feedback. I'll talk more about this in 10 minutes, because this needs a few slides. We give these models to whatever company wants to use our models. Key difference, we don't ask companies to send their data to us. We give them our models, and that is the last time we touch these models. Because we give these models to you, you can fine-tune these models on your code bases and your data, and easily give these models access to whatever resources you wanted to have access to. Like you would do with a new developer that you onboard in your company. They can only do their best work if they understand how code is developed within your organization. They can only do their best work that if they work on something, that they have access to your Confluence documentation, to your Markdown, to your Jira tickets. It kind of makes sense that you don't want to send all that data over to a SaaS product. These then become your company's models. We continue to train new models, and when we have a better model, we give it to you, and you can refine-tune it and retrain it on the things you want to train it on. End-to-end. This also comes with the assistance you're used to today in the IDE. It comes with an API, it comes with apps. But if you believe that AGI is coming for software development, then these extensions in the IDE will become less important over time. They'll still have their place, and this is what we're doing today to meet the market, but it will be different in 3 years. We announced this at reInvent in Las Vegas last year because we have a special relationship with AWS. And 2 weeks ago, we finished training of our latest 2 foundational models. It's a code completion model named Point, and it's a chat model named Malibu. Again, these are models we give to you. And key is, like we're at an AWS event, when we give these models to you, you can deploy them in your VPC or through Bedrock and train it on the data that actually matters to you. Because again, these general purpose models there's no way they can understand how you develop code within your organization, especially as organizations become larger. This becomes a bigger frustration with general purpose models. This has huge benefits because you have your contracts with AWS, you have your hardware in AWS, and we, as a first party for AWS, you don't have to deal that much with Poolside. You can leverage the relationship you have with AWS. Huge benefits for you as an AWS customer. It also saves us a lot of time because we're a 2-year-old company, founded 2 years ago, like after many days and nights of JSO and ISO chatting about this topic. And as a young company, it is hard to open the door in bigger companies, but those are the only companies we talk with today, companies that have over 5,000 developers and that realize the strategic importance of owning these models. So, companies are at a point now where they rethink how they want to go about AI models. They see these models are becoming a strategic asset for them because these models need to have access to their data. So what makes Poolside then so unique? If you use any of the AI products for developers today, and this is what I do day in and day out, not just with Poolside models, but also with Copilot and with Cursor, then these models do a good job when it comes at vibe coding. Like you see many examples on LinkedIn these days about vibe coding. Someone who hasn't ever built a application, but now suddenly builds its first application in a week just by prompting the LLM, can you please build this web application for me? That's fine. There is a good place for this. And if you're not a software developer yourself, then it's amazing what these products can do for you. When we think about high consequence code and high consequence companies like your company's data, then vibe coding probably isn't something you want to do too often. But you still have to deal with the fact that these models act like as a really good junior developer. And you need junior developers within your company. But if these models cannot go beyond that ceiling of a junior developer, then you will always be stuck in hiring someone who isn't leveling up. And I hope when you hire developers that you want to enable them to get better at their job and to become senior or one of the most senior developers within your organization. So again, this is why we created Poolside. It's the foundation that companies build on top of. We provide the IDE experience, we provide the APIs and the apps, but the core of this is this software intelligence layer, which is the model, but also the context engine of this model. And with this context engine, I mean nothing more or less than the access you would give a typical developer in your company to your company's data and to your code bases. When I join a company as a developer, I probably spent the first 6 weeks or so just browsing through the code bases that exist within their company to exist, like how do they develop code in the first place. I reach out to people in Slack or in Teams to ask questions about these code bases. I pick up my first Jira ticket and get to understand how decisions are made within this organization. We need to think about models for software development in the same way. We need to treat them like developers that we can level up. And you can only level them up by giving them the data they need. And by doing this, you do not give away any leverage, or you do not create a dependency on the SaaS products as they exist today. Okay, boiling it down to the 3 key pillars of Poolside. It's model intelligence, how we make a difference when it comes to model intelligence, why we got funded so much money to build this model. Relevance, like what actually matters to you as a company, and last topic, security. Let's start by talking about model intelligence. Companies are throwing a lot of compute at this. We at Poolside, as of today, only have 10,000 GPUs. I think we're in the top 10 of companies out there in terms of number of GPUs. But if you compare that to how many GPUs OpenAI has, we're relatively small. So how is it possible that we can then actually move the needle with only 10,000 GPUs? This comes down to how we train the model. Because you can throw a lot of compute at this problem, But all these models still rely on the same data. Little known secret in the AI industry is that we all rely on the same data sets. What's in the public domain? When you visit github.com, everything that has a license that you can actually use to train the model. Stack Overflow, Hacker News, like all those trustworthy sources that you then can use to train the model. With a big difference is that general purpose models are trained on everything on the internet. So you can ask a general purpose model whether I can feed my dog an avocado, and that knowledge then exists in the model you use for software development. But that means that these models are not so efficient because they have huge amounts of data that you don't need to do software development. So think about the training data for code as follows. All the code on the internet. Half of that data, you're allowed to use it as a model maker. And let's trust all these model makers that they only train on data that has the right license. What's left? 50% of the code you started out with. Then you remove duplicates. The number of forks on GitHub, it's enormous. You're not going to train the model on code that already exists within that model or in that training set. Then there's a lot of shit code out there as well. Like if you check my GitHub profile and you want to train your own model, I think only 20% of the code on my GitHub profile is useful for you to train the model. That leaves us with 10% of useful code in the public domain you can actually train the model on. And all model providers are training their models on the same data set. And what they cannot do, as LLMs is next token prediction, is actually check whether that code is valid. What next token prediction does is you give it a piece of text, you take away a piece of that piece of text, and you ask the model to guess what most likely that piece of text should be. If it guesses right, you give it a thumbs up, otherwise thumbs down. The same is happening with code today. You give it a piece of code, a piece of that code is missing, and you ask it to guess what that piece of code is. If it does a good job, thumbs up, otherwise thumbs down. What if there is a reality where we can train models not what code should look like, but actually how to code? How you all started off as a developer on your laptop, on your computer, in your IDE, just writing code, seeing that it doesn't work, trying it again, hundreds of times over and over again, and reminding yourself of what actually works and what doesn't. Nobody learns how to code from a textbook, but that is what general purpose models do. So this is what we do at Poolside. We train models how to code. And there's another benefit to this, and that is synthetic data. But let's first talk about how to train the model how to code. So again, situations today, you give it a problem, there's a missing piece of text, and you ask it to provide output code. If that output code is good, thumbs up, otherwise thumbs down. Instead, and this is our proprietary technology, reinforcement learning through code execution feedback. I will say these words a couple of times. Today, if you come to our booth, I will ask you whether you remember this long name. It took me a few days at Poolside to get used to this. But it's reinforcement learning through code execution feedback. But it does give away what it actually does. You give the model a task. You ask it to write code for that task, and it starts doing this. And every time it does this, you try to execute that code. If it executes, you test the code. If it executes, if it's tested, if everything is green, you run performance tests on that code. You try to deploy the code. Again, all steps we would normally do as a developer. This is what Google did with AlphaGo. Maybe some of you remember AlphaGo, how traditionally we try to learn AI how to play the game Go is by giving it the ability to look at two players or many players play Go and analyze that over and over again, see what moves lead to a winning result. That led to a good Go AI player, but not the best one. There were still human players that were better than the AI player that they developed. Instead, what they did, they let the AI play against itself. It played Go all day long, many times in parallel. And every time a winning move led to a winning outcome, you would reward the model for doing something that made it a good Go player. This today is the best Go player we can think of. We do exactly the same through reinforcement learning through code execution feedback. We ask the model to write code all day long, many times in parallel. This is what our 10,000 GPUs are doing at the moment. So this is what we call the model factory. And this leads to a significant difference on the output provided by the model when it's used by the end user. I'll give you a data point in a minute, but first I want to boil it down to one TLDR. What it does, take 500,000 high quality open source code bases from GitHub. You go back to commit number 1 or commit number 100, commit number 5,000. You check what issues are open within that repository, and you ask the model to come up with 5,000 different solutions for the issue that is open in that repository for that code base at that moment in time. It starts working on this, it goes through the steps of executing it, testing it, performance testing, deploying it, all the things you do as a developer, and every time it does that well, you reward the model for doing the right thing. And then you have a model that actually understands how to code. One data point. It's an older data point, but I think it's really telling. So the 6.7 billion number of parameters in the model is an open source model. You can probably run it on your own local machine. If you give it 10,000 coding tasks, I believe this was in Python and Go, it's able to complete about 29% of these tasks successfully. Now, GPT-4 Turbo, it's a much bigger model than the open source model I was just talking about. 39.7%. Now, one thing I didn't mention about training the model how to code is that it generates synthetic data as it does this. So I was talking about this ceiling of the data that is available on the internet. Because it is writing code all day long, high quality, tested, deployable code, we create new code. We can add a synthetic data to that data set we train a model on. So 2 things, we train the model how to code and we generate new code for this as we go. If we add this new synthetic code to this model, then it surpasses what GPT-4 Turbo can do. Just by adding the synthetic data to that open source model. And this is, I think this data point is already 5 or 6 months old. We continue training the model and releasing new models. But from such a small open source model, how far we can move the needle by adding that synthetic data, it tells a lot about how proven this technology is. So Malibu and Point, those are the 2 models available today. Those are the 2 models that some of the biggest companies in the US and Europe are playing with as we speak. Because that's what we focus on at the moment, larger organizations. Malibu and Point, I believe about 10 to 20% of the data in those models went through reinforcement learning through code execution feedback. Bandai, the model we're training at the moment, and the model we'll release later this year, it will add 50% useful code on top of the useful code that is available in the internet today. So we at Poolside have the largest data set of code you can train the model on. Plus we train the model to actually code instead of doing next token prediction. Okay, so that's how we train the model. That's one of the reasons we're unique. But there's another thing I already alluded on, and that is relevance. We can give you the best model, but if it doesn't understand how you work as a business, it is just the best model. Think about hiring one of the most senior developers in your industry, in your company, and not giving it access to any of the relevant information they need to do their work. Then you have a very expensive developer that cannot do their work. So how we go about relevance is in 3 ways. Because we give the models to you, we allow you to fine-tune the model. You give it your exotic code bases, legacy code bases, best practices, examples, all the things you would give to a new developer within your organization to understand how you code as a company. But there's another tool, Greg. Like a developer learns from spending time in code bases, there is also information they need to look up while they do their work. They need to look up that Jira ticket, Confluence documentation, something in Slack, a discussion they had the other week with someone, an email. It can be anything. So there's the working memory and the information a developer needs to have access to. So that's the second pillar of making this relevant, and you can only do this by making sure the model is close to your data. And then the last gold mine, and this is more of a traditional abbreviation in AI, is reinforcement learning through human feedback. This is how still models are trained today, by the way, is by providing it feedback on the suggestions it gives. Because you own all the data, you can store all the telemetry that is relevant for you on how code is developed within your organization and how Poolside models are used. So let's say a developer accepts a suggestion and then makes an edit in that suggestion. That's really important information for you to have if you want to further fine-tune this model on how developers do their work within your organization. So that's the last pillar of this. Like it's really a gold mine to have this data on how developers interact with the model and with your code bases. So relevancy, like really keep that in mind when you think about using AI in your software development workflow. The last, and for some companies the most important pillar of this, is how do I keep this all in control? Because when these models become more powerful, and they will get more powerful, like compare what we have today in the market versus 2 years ago, you don't want to lose control over this. You don't want to have a strong dependency on something somewhere in the cloud where you're not 100% sure what happens with that data you send to it. Where you want them to delete the data you actually want to train on through human feedback. So you don't want to lose control of that software intelligence. And today, like there is typically the extensions you use in the IDE, they have access to the code base, the workspace you have open in your IDE. Maybe some additional code bases in GitHub or in GitLab, Bitbucket, somewhere else. But the reality of all of this is that all these other tools in your ecosystem that your developers use day to day are tools models need to provide better results, to do more work that developers do today, to be more powerful in the hands of a developer. So, summarizing this, Poolside is here. We exist because we want to get to AGI for software development. We do this by building foundational models for software development. So only focus, creating the best model for software development. We do this end-to-end, from the model to how this model is consumed. Today, model is consumed typically through the IDE, but you can imagine a world where this is consumed through an API. For example, whenever new code is added to my repository, I want it to automatically write new unit tests for my for this code base. It can do this because it understands how you work as a company. It understands your business. It understands how you go about software development. And this then is yours. It is the model you own. No trade-offs. You are in full control of software intelligence for software development. That's it. Thank you all for joining. We have a booth, G15. I would love to continue this talk face-to-face with you and have some discussions about what software development will look like in 2 to 3 years. A lot is changing at the moment. Not all companies know what to focus on. So let's please have that discussion later today. Again, thank you all so much for joining. It's a real pleasure to be with you here today.